Hello, everyone, and thank you for joining us on this webinar brought to you by the McMaster Alumni Association. My name is Robert Boshra, and I have a PhD in biomedical engineering and a master's in neuroscience. And I'm here to talk to you today about AI teaching computers to think and solve puzzles. So just a little bit about myself. I study machine learning and artificial intelligence, and I teach computers how to help me look at all the great things that the human brain can do. I use a device called the EEG that you can see in the picture over there. And machine learning helps me look at all the things that come out of it to understand how the brain does what it does. So I'm very excited to get into your questions, and we will start with Jacob's. So Jacob from Burlington is asking, how do computers learn to think like humans? I think that's an excellent question to start, because it kind of guides the entire webinar today. So first of all, the brain. I know that there was a webinar just a couple of weeks ago, and the brain is this fantastic organ in the head, and it does everything that a human can do. And the brain has all these little neurons that send signals across the brain. And these signals are basically the underlying thing that give us thought and creativity and all the exciting things that we can do. So if we try to look at what these neurons do, we see those little squiggly lines on the bottom here. And so if we try to look at a computer in comparison, we find the CPU, so the central processing unit. This is something that you would find in your laptop, in your computer, even in your cell phone. And how the data and how it talks to itself basically is all in ones and zeros. And which is very different from what the brain does, right? So how can we make that do, how can we make the computer think like a human, right? They're so different. So let's take a simple example at the beginning. So if we have the human brain, and I'm trying to play this game of Pong, and so the game is I'm trying to prevent the ball from falling through the bottom of the screen here. So the way I would think of it is, okay, so I will try to move that paddle where the ball is. So if the ball is to the left of the paddle, I move left. If it's to the right, then I move it to the right, which seems pretty straightforward. And you, with using programming, you can actually put that in a computer and make it follow that one-to-one, okay? But is that really intelligence? Is that now thinking like a human? Maybe just a little bit, just in that very simple case. So move on to chess, which is so much more complicated. Now you have to think of, oh, like what pieces do I move? Like how do I take it from here? And what did my opponent play in the beginning? And if I try to put this into words, I wouldn't be able to do it. And this is where artificial intelligence and machine learning come into play. These are the kinds of things that we want a computer to learn to do similar to a human. So ideally, I would want to have a couple of robots or a couple of computers, and I would just tell them, well, this is how you do it, and I teach it just a concept of how to do it, just like I would teach you how to play chess, and you kind of figure it out from there, right? But a computer can't do that. So we need to come up with a way, an algorithm, to get it to learn that step by step. So let's look at an example of trying to tell the difference between a cat and a dog. Let's say you have a computer, and that computer takes in an image, and we want it to tell whether it is this or that. And for that, in order to make the computer try to think like a human there, we get a large group of images that are of dogs, maybe in different ways, different breeds, looking at different directions, and do the same thing for a cat, for cats. And what we do is we present the picture of one cat, and we give it to what is called the machine learning algorithm. So this is kind of the process that the computer learns by. We show it that, and in the beginning, the machine learning algorithm is very silly. Like it doesn't really know what it's seeing. So let's say it says, "Oh, I see a dog," right? So because we already know that it is a cat, then the algorithm gets the feedback from us that says, no, 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 this is not a dog, it's a cat. So the machine learning algorithm looks at it's how it understands the problem, and it adjusts things a little bit. It says, oh, like if I tweak these two things, maybe I can be a little better in the future. So it does the same thing with, let's say, a picture of a dog. You give it to it, and it's like, oh, is this a cat? And you're like, no. And it feeds back, and it adjusts things a little bit. So do this thousands and thousands of times. And what you end up with is what is called a model. What this model does is if you give it a picture, and let's say I don't know whether this is a cat or a dog, and I give it that picture, it is, at this point, it should know, oh, this is a cat, and then I can know it is a cat. Okay? So, but I've been telling you about this model, and I just put this weird icon in the middle there. What is that actually? And one of those models is called a neural network. Neural here is coming from the brain, because that cell in the brain is called neuron, right? And you put these layers of neurons and get them to talk to each other in a way that looks like the brain, in order to think like the brain, right? And each of these layers is a simplification, is a very simple way of putting that little neuron in form, okay? So, but then you can think, okay, well, but we have neurons and we have all these things. How can you make these neurons into ones and zeros? Well, you do that using math. Math is a fantastic tool that you can use exactly for that. So if you're somebody that likes math, maybe a few years from now, you can type in and put into computer equations that can make that exactly work. But even if you don't like math, there's still packages out there and code out there that you can use to make this happen even without knowing math that much. So I hope that gave you an overview of like how you can make a computer do things a little bit similar to how a human would do it. So the second question from Lauren: how does YouTube know what videos I like to watch? I really like this question because I use YouTube all the time. So actually, to answer this question, I took a screen share of my own YouTube recommendation. So lately, I have been trying to learn how to draw and how to paint. I've been reading books, and to do some research for this talk right here, I've been looking up robots. And if you look at my recommendation, you're going to see exactly that, the things that YouTube thinks are good for me. And so how does it do that? It does that in 3 separate ways. So first, what have you been doing, Lauren? What have you been watching? Have you been watching a kind of video for long, or have you just been clicked on it and be like, oh, I'm not interested in this, and then you click on something else? What is that video like? Does it contain cartoons? Is it about games, science, space? And it also thinks, oh, like you like this channel, so you probably like more content from that same channel. And then it looks at videos themselves. So let's say the video has specific titles. Let's say it's about books, or let's say it's about painting. So in the title, it says that. Also in the description, it says a bunch of stuff like that too, right? And all that relates, and it uses something in machine learning called natural language processing, which is the study of language for the computer to try and understand what the content is all about. So video title, description, and then it also looks at the views. So it knows that if a video is good, a lot of people are going to watch it. A lot of people are going to like it, and a lot of people are going to press on the dislike button. And generally, it recommends videos that have received a lot of views and have been liked, right? It doesn't want to give you bad content. And the last piece, which I find really cool, is it tries to look at people that are similar to you. So if you, let's say there is another person that is around the same age, watches around the same things that you are watching, and let's say that other person liked a video, then in YouTube's quote unquote brain, it associates you with that other person that is similar to you and gives you that video that the other person liked. So all of this describes something that is called a recommender system. And that recommender system is what allows us to take from thousands and millions of videos to only a few that are recommended to you on your homepage. Nash asks, how do driverless cars make driving decisions if they can't see the road? Great question. So the way robots are built is that they hide their sensors in ways that don't necessarily look like human eyes. So this is a robot that is very dear to my heart because I worked on it when I was doing computer science at Dalhousie University. And this robot's eyes was that little thing pointed at with the red arrow. So that is equivalent to eyes for a robot like Wall-E, right? So how does that transfer to cars? Well, self-driving cars have a lot of sensors that don't look like eyes. They have ultrasonic sensors to see if something is close. They have cameras usually on the top, and they have sensors on the side to see if you're getting close to this or that side. And also their vision system, the way the camera, the video coming from the camera is processed, is it takes from, if you look at the bottom left corner here, it takes this usual thing that you can see with your eyes or through a camera, and using artificial intelligence, it identifies different places like, oh, this is the sky, I don't need to pay attention to it. Oh, this is the road. Oh, this is another car, so I should watch out for it. And information coming from all these things go into the decision maker, which is another piece of machine learning or artificial intelligence that allows the computer in the car to actually navigate and plan its next move. So the next question from Julia is asking, are computers smarter than humans or just faster at making calculations? I love this question because if you actually think about all the fantastic things that computers do on a daily basis, you could start thinking, oh, like I'm not that quick at math, so maybe my computer is smart than I am. But the thing is, no, not at all. So computers can be faster in calculating things. Computers can store so much data, terabytes and terabytes of data, so much more than a human can remember. And they can do very specific tasks for very long without getting bored, they keep doing what you tell them to do. But what robots and computers can't do is use that information between different things. If you get a computer that knows how to play chess and you tell it to play checkers or Go, it's going to be completely lost. It won't know what to do. And it also doesn't do other things that people are really good at. Things like being creative, planning, and helping computers learn, right? It's maybe in the future that will change and computers will be a little smarter than now, but right now we are so much smarter in general. And that is also the case if you look at things like, do you know CAPTCHA? So it's that little test usually on websites that tries to prevent computers from accessing it because it only wants human beings to do it. So something as simple as select all images with sandwiches, it would be easy for you to do it, but for a computer, it might be able to do it, but it's going to take a very long time that it's just not worth it. Also, you can hear a lot of people talking at the same time and maybe follow different conversations, computers have a really difficult time doing that. So yeah, computers are not smarter than you. They just do specific tasks quite well. Could AI ever express feelings? If no, why? That we can get very philosophical here. I think right now that is not the case. So I wanted to tell you about something called the Turing test. So this is when you have one person sit down in a room, very separate from two other rooms. In another room, there is another human, and in another room, there is a computer. And those two try to convince the very first person that they are human. So, and they keep talking, but this is all through chat, so they don't know. And today, some computers can actually convince that person that they are human. Isn't that fascinating? They can be like, yeah, I feel happy, I feel sad, and they can talk about their families and they can just make things up. But the thing is, does that actually mean that they are feeling things, that they are understanding what they say, or is that just some things that they memorized and are faking? So today, I would say that every single case of a computer that is trying to feel and be more human-like is faking it. It's not real. It might change in the future, and I will be very excited for that. But today, that is not the case. Lucas is asking, can robots who look and act like humans really ever be made, like in the movies? So I think we can look at three different things. So first is movement and shape of robots. I think there are really good researchers out there that actually make robots that move in very human ways. If you look at that video on the right here. So I wouldn't even be able to do that, but they move in human ways, right? Very, very cool. In terms of look and maybe more of the face, you can see robots or androids is the proper term if they look like humans, that have this skin-like thing, and they're a little creepy, but you can start seeing that they look human, right? But even with that, I would say that the one main part about all this, the brain of these androids, is nowhere close to a human brain. So you can see those androids or like human-like robots in movies like the ones on the right here, but the combination of movement or shape, look, and brain is not there. In the future, I think it's going to be possible to get close to that, but right now, unfortunately, no. So next question is, what are the chances that wars will be fought by AI in the future? That that's a really good question. So I have to say that wars nowadays, I wouldn't be surprised if wars nowadays use AI. So there is this very big part of the US government called DARPA that looks into all these different bits and pieces of new intelligent computers in order to make wars easier. And they come up with these drones that are autonomous and go out and do things. And I'm pretty sure all these rooms that have people analyzing things, they do have artificial intelligence and machine learning in the background that are helping people out. They might not be making decisions at this point in time, but they're definitely used in stuff like that today. So, but war in general is like, let's put that to the side. But if we just look at the defense, I was actually very fortunate to play with this particular project with in back in Halifax and Dalhousie, where we were trying to make little pieces of software, little computer software that helps submarines automatically go through the ocean and put maps of what the ocean bed is like. And while this is related to wars and the army, that's a very cool application that can be used in vehicles that are used in these things. Sophia is asking, will computers eventually replace all workers? So I think the very simple answer to that is no. I think that they will replace a lot of different types of workers. So if the worker, that the kind of job that the worker is doing has to do with something that can be repeated and then that can be taught to a computer, probably that's going to take place in the future or near future. But with that happening, there are going to be all these new jobs about making robots and about making them smarter or creating them from the ground up. So with stuff that are going away, there are stuff that are being introduced. And yeah, and this happened even with when the introduction of computers from the start, right? People were also afraid of computers overall. But it's the same thing with robots and machine learning. And I think it might give us a little bit of time to do the things that only we can do and be creative, write books and go outside and enjoy our time and let them maybe do the boring things. So Karen is asking, how soon will it be that we don't need picture ID or passports to confirm our identity? Great question. I think we already have the technology to make that a reality. We have something called biometrics. So you can identify a person by looking at maybe their fingerprint, that's very old. You can by the footprint or the way they talk, maybe by the imprint of their eye or the iris or cornea. You can do face recognition, and you can even implant little things that are under the skin, which allow you to know exactly who that person is, right? So we have all this stuff that is already there. We also have the phone, which is pretty much a moving passport that everybody has nowadays. But what is preventing that from happening, I would say, is if you want that to become mainstream and everybody to use it, that needs to be very secure. It cannot be faked, because that would be very bad if somebody can make it seem like there's somebody else or maybe steal from a person that they're impersonating. So I think security is really important here, and in order for that to be all around the globe, that will to be very strengthened. It also needs to be cheap, because paper is cheap, but maybe putting things in our bodies might be a little bit more expensive, right? Also, it needs to be adopted by a large group of people around the globe, because yes, we have the technology, but we need a few companies, a few countries to start doing that in order to people to start being like, oh, let's all do this and move towards it. So to answer the question, I think that's probably going to happen within, let's say, 10 years, but I wouldn't say beyond that. So John is asking, what is the biggest opportunity and limitation of AI? That is a very good question. I think these are four very excellent places for AI to hit right now. And AI helps so much with new discoveries and in science in general. You can use it to help you look at different data. This is what I do. I use machine learning and AI to make me do my science better and make it faster. I also know that in NASA, and they are using AI to help guide the rockets and help make sure that scientists focus on what they need to do, but everything else is automated by machines. It's very, very cool. Recommender systems. So it's not just YouTube, it's YouTube, Netflix, maybe even like papers if you do research. All of that is very useful to look at with AI. And I think one of the really up and coming things right now is healthcare in hospitals, and how AI is helping doctors and nurses and patients be better and get cared for better. It's going to be very, very good as AI gets more integrated there. So now on limitations, I mentioned before this that limitation of AI is that it's quite limited. And if you surprise it with new things that it hasn't seen before, it tends to really fail. So this is something that we can't have, especially when it comes to, let's say, like piloting a plane. Like you need to be confident that whatever it sees, it's going to interact well. And this is where humans are very, very important. And one really funny example here is, let's say we have this classifier there, this model that I mentioned before. And if this model was trained to look at bananas, and this is actually a real thing that happened. If you give it that banana in a picture, it's going to be like, yeah, I am sure this is a banana. But if you put that little sticker, that very weird looking sticker that I don't really know what it means, but if you put that and stick it right beside the banana, all of a sudden the model is like, I am sure that this is a toaster. You can't have these things happen, and I think this is the primary limitation in AI. So the last question from KN is, what is the most amazing thing that a computer can do? I left this one for last because it lets me just pick and choose and be subjective and show you the things that I find really cool. So I actually cheated a bit, and I took more than one. So I think there are two that are really, really cool things computers can do is sort through email. I spend so much of my day looking at emails, and the fact that a computer just goes through it and be like, nope, that email is not good, that email is not good, and gives me only things that are relevant to me, that saves so much time for me and for everyone else. Might not be so cool, but to me, it's very helpful. The other thing is the fact that we can talk to computers now. If you go back 10 or 20 years, that was science fiction. Everybody would be like, you can't do that. So the fact that we have this with our phones or Alexa, or if you talk to a Google device, that's amazing. But the one thing that I choose as the coolest thing that a computer can do is, I believe this is under Google Translate, and it's where you can use your cell phone, and if you go to a country where they have signs or documents that are written in languages that you don't know, you just pass the camera on it, and it finds the text, identifies what language that is, translates it, and puts it on your phone directly. I think that is straight science fiction. The fact that we can actually do that and all of us can have that in our pockets nowadays is fantastic. And you can actually use it to visit all cities in the world without worrying about getting lost. A++. So before I call it, I just wanted to share a couple of links with you that I think if what I just spoke about was interesting to you, I think it's quite worth pursuing and looking into a little bit more. So the first link over there is different projects that are very approachable, and that if you want to create your own little device or your own little software that can tell apart cats and dogs, you can do it. And there is an example for you to how to do that there. If you want to create a chatbot that replies to your messages, it's all there. I think it's amazing. The second link over there is Pictionary, but you play it with a computer. I think it's fantastic. And it actually shows you and it tells you what it's thinking, what you're drawing, and it can actually tell you how other people drew those things. And the last two here are just other resources if you're interested in machine learning and artificial intelligence in general. And if outside of these things you have another question that has nothing to do with these, by all means, please feel free to send me an email and I'll do my absolute best to reply to you quickly. And with that, I really hope you learned something new today. And can share it with your friends and family and tell them about all the cool things that you heard about. Thank you for joining today, and thank you for a set of really great questions. And we will look forward to your questions on the next webinar. Thank you. Have a good day.